All right, today we are going to take our first steps towards really solving some big polynomials, okay? Uh, and the key method we will be using in our class is factoring polynomials. And we played with factoring a little bit last semester uh, when we were solving just quadratics, x squared equations, but now we're getting much bigger. In fact, what I've got shown here is an x cubed equation. So that's this equation right here graphed. Now remember, what we're looking for when we end up solving these equations are the zeros. Where does it cross the x-axis at? And those are our solutions. And the way we can find those, besides using a graphing calculator or using Desmos, is we can learn to factor these things. Today, the methods of factoring we're going to review are the ones we've already done: greatest common factor, and then how to factor a trinomial. Uh, so let's go ahead and get started. Real quick, I'm going to show you how this one would factor. I'd start with this guy right here, and I'd say, well, there's a common factor. They both have plenty of x's in it. The first one has x times x times x. The second one has a 1 times x. And so we could take out a factor of x, and it would look like that. So if I were to redistribute, this is x cubed minus x. So it's still equivalent to this line that we started with. And this is what we call a difference of two squares. We'll be covering that. You can see that's our third thing we'll be attempting to do. But this factors as follows: x minus 1 times x plus 1. And once we get it factored, we can use, if you recall, the zero product property. And that just says you can take each factor, set it equal to 0, and it will tell you the zeros of the function, or tells you where it crosses the x-axis. So this should cross at 0, x is 0 right there. It should cross when x is 1 right there, and it also crosses at -1 right there. So if we can get a polynomial from its standard form into a factored form, we can actually find the zeros or the solutions to that polynomial. All right, now there's various steps in factoring this guy. This next slide kind of shows you the process that we're going to be going through. And today we're just going to be working on the right-hand side of this little tree diagram here. But when you factor a polynomial, the first thing you're always going to do, I guess I should say, put it in standard form first. But the first thing you do after it's in standard form is you always look for this greatest common factor, something that you can unmultiply, undistribute, and take out of every single term that's inside the polynomial. And then once you've done the GCF, you'd have to make a decision. If it's only got 2 terms left over, we've got special factorizations that we'll memorize. But if it's got 3 terms left over, like today's, we're going to undistribute that. And I'll show you a process for doing that that's relatively easy. It's not factorable. Back here, I said, always look for a greatest common factor first. I didn't do it on those last 3 because we weren't. If we're trying to factor with 2 terms, we have some special ones: difference of squares, difference of cubes, and sum of cubes that we should know. Now, you don't have to know those formulas, at least not for the difference of squares. You can actually work that. So let's take a look at a greatest common factor problem. Now, on the left-hand side, I've got the original problem, and that equals, and I've just written the original problem again. And so I just want to show you that this is always equivalent. So on the right-hand side, I'd look at each term. I got an x cubed, a minus 5x squared, and 15x. The first thing you would check is coefficients, but this only has a coefficient of 1 right there. So the biggest number everybody is divisible by would just be 1. That doesn't do us any good. Then we look at our variables. To decide on what variable you can take out, just look at all the x's, and you want the lowest exponent on any of them. In this case, a single x to the first. And so what we do is we unmultiply that. So we divide everybody by that x, essentially. And you can see I factored out that x. It's still x cubed minus 5x squared minus 15x, but I have taken out the greatest common factor. These three terms left in here, they are not all divisible by the same thing. So this is just the GCF. We will be trying to factor this later on. This turns out to be what we call prime. I did that on purpose, so we didn't have to even bother with that right now. So this would be the factorization as far as we could go for this problem. Our next example, same thing. I've got the problem originally here, and then I'm going to just, same problem there. I'm just going to work it down on the right-hand side. And so I look at my coefficients first. We've got a 5, a 10, and a 20. And I just have to kind of think to myself, what's the biggest number that all of these are divisible by? And everybody is divisible by 5. So I'm certainly going to divide everybody by 5 and factor that guy out. So I'm going to put equals, so I'm going to pull that 5 out. Next, I'm going to look at my variables. It's x to the fourth, x cubed, and x squared. They have at most, all of them, an x squared in them. Again, that's the lowest exponent on any of the x's. So I'm going to pull out that x squared. And that leaves me with, so I'm dividing this essentially by a 5x squared, leaving me 5 over 5 is 1, and x to the fourth over x squared, I've just reduced that to an x squared. I divide this 10 by the 5. That gives me negative 2, and I take an x squared away from the x cubed, leaving me just an x, and I'm pulling that 5x squared out of this. 20x squared, 20 divided by 5 is 4, and x squared over x squared is 1. So I'm going to rewrite that so it's a little neater, but it is 5x squared times x squared minus 2x plus 4. And this is our GCF. The greatest common factor, the largest thing, the largest term we could factor out of each of these terms. You can see now, and you always want to go back and check, this one has a coefficient of 1, so I can't pull out any other numbers, and 4 doesn't have any x associated with it, so I could not take any more x's out of everybody. And so we'd be done right there, just the GCF. Now, this obviously gets more complicated because, well, again, this one I've set up to be prime right here, so it can't be factored. But many times, this will be a factorable trinomial. So we're going to take a look at the process for doing that. That's pretty efficient. So here we are, factoring trinomials. And you can see all these directions are based off of being written in standard form. Ax squared plus bx plus c, okay? And in order to factor one, what you want to do is just find two numbers, and I've seen them called different variables, but we're calling them R and S, okay? And you want to find two numbers who multiply and give you the C value. So they have to have a product of C, and at the same time, they have got to add up to B, the middle term. So we're looking for an R value and an S value who multiply to give you the constant, the C, and who add to give you the middle term, the linear term's coefficient. So let's take a look at this example I've got here, okay? And so a really easy thing to do is to write down the number 3, okay? Because that's the C value. I should have done him in blue. Let me do him in blue so you guys can recognize that's what I've got highlighted there. I'm going to take the number 3, the constant here. That's my C value, okay? And I want to find two numbers, and I'm going to call them R and S, whose product is 3 and whose sum is 4. Well, 1 times 3 is the only factors that give you a 3, and it turns out that 1 plus 3 is also equal to 4, so we're certainly going to use a 1 times a 3. It meets both those conditions. The product gives you the C value, 3, and the sum gives you the B value. Let's write him in red, or green. And the sum gives you the B value of 4 right there. And so now we can factor him. It's going to be an x times x. It's got to be a 1 and a 3, and they were both positives, plus 1, plus 3. Now, when these problems get more complicated, what you're continually doing then is at the very end, is you go back and you check it really quick. So you can either do it mentally, x times x times 3, or you can just kind of work it out really quick, 1 times x and 1 times 3. X squared plus 4x. Yeah, it does equal the original problem, so we know we are correct. So our final answer would just be that x plus 1 times x plus 3. Let's look at one of these a little more tough or a little more complicated. Here we go. This time we want to get our product to equal 10. That's our C value. Okay, so 10 is what we're going for. Here's our R's, here's our S's. It could be 1 times 10, and I like to write my sum right off to the side. Those add up to 11. It could be 2 times 5, and those add up to 7. So clearly, that's the one I want. Okay, and so let's try it out here. I'm going to use an x and an x. That would give me my x squared, and we think it's a 2 and a 5, positive, positive. Okay, and then I'm going to distribute just to double check it. I'm going to show that check down here so I don't have to rewrite our answer. So I distribute, that's x squared plus 5x. I distribute, that's 2x plus 10. I add those like terms in the middle. Yep. This checks with the original, therefore I know that is the correct way to factor that polynomial. Last example of this type, we haven't done any with any minus or negative sign. I think this is the last one like this. Let me look here real quick. No, 2 more like this one. All right, this time my C value is -6. Now that's going to be important. So -6, and here's my R, my S. What that negative tells me is one of these has to be negative. So it could be -1 times a +6. That would add up to a 5. Or it could be a +1 times a -6. That would add up to -5. And yes, look at that. My sum I wanted was -5. My middle term is -5 right there. The product is -6. So I'm good to go. And I just write down the answer. To get x squared, it's got to be x and x. To get the the -6, it's 1 times -6. And the 1 was positive. And so that should be the correct factorization. Let's run up to the side here and check it. X plus 1 times x minus 6. X times x and x times -6. And then 1 times x, that's 1x, and 1 times -6. Like terms in the middle, -5x minus 6. Yeah, that checks with the original, and therefore that is the correct factorization. One more. This one had 2 minus signs in it. Okay, and in general, everybody, if your C value is negative, like this one is, it turns out that one of these will be negative and the other one will be positive. They have to have opposite signs because their product has to be a negative number. It's a little different. No, it's not different. This one, so right away you'll notice here we got a negative. That means one of our values will be positive, one will be negative. We're going for a -12 here, so let's write that guy down. R and S. So it could be 1 times -12 or -1 times +12. This adds up to -11. This adds up to 11, so neither of those work. It could be 2 times 6, -6, or -2 times +6. Here the sum is -4. Here the sum is +4. So neither of those work. Remember, we're going for this B value of 1 right here. Let's try 3 and -4. That multiplies to -12. It adds to -1. -3 and +4 adds to +1. There's the combination that we want. And so we should be able to factor it now as x, and it's going to be a -3 and a +4. Let's run over here and check it. X minus 3 times x plus 4, distribute, x squared plus 4x, distribute, -3x, distribute, -12, add up our like terms, x squared plus x minus 12, yep, that checks with the original, and therefore I know I am correct, and I factored it. At this point I could go forth and find my zeros, but it wasn't an equation here. We aren't solving it, we're just factoring it. All right, now we're going to combine these two processes. We're going to look for a GCF first, which is always our first step, if you remember, practicing that at that point. But now we are putting it all together. So again, I've got the original right here, and just a duplicate of it here, so I can just kind of work down on this right-hand side. So I'll look for a GCF. Well, coefficient is 1, so there's no number I can take out. This has got an x cubed, x squared, and an x, so the most they have in common is an x. So I pull that x out, leaving me x squared minus 4x minus 5. But now I'm going to try to factor this trinomial. Okay, so it's -5 is my c value, and I'm going to look for my r and s. Well, to get a 5, it's got to be a 1 and a 5, or -5, or -1 times +5. Here they add up to -4, here they add up to +4, so I certainly want to use this line right here. And so I have to keep track of all my factors. I already have this x outside, so I have to rewrite him. But now this trinomial can be rewritten as x plus 1, this guy, and x minus 5. And I'm going to go over here to the left-hand side. I'm going to check him real quick. And I distribute x squared. I distribute -5x. And I distribute the 1, 1x, and distribute the 1, -5. And that gives me x squared minus 4x minus 5. But I have not yet multiplied this x times everybody. So he has to get distributed, giving me x cubed minus 4x squared minus 5x. X cubed minus 4x squared minus 5x. It checks. I am guaranteed I have the right factorization. So again, you just do the GCF, and then you use that little RS method. To left. Okay, so I'm working on the right-hand side. I'm going to look at my numbers first. I got a 3 and a 48. Well, 3 and 48 are both divisible by 3, so I'm going to pull a 3 out for certain. Now look at my variables here. I got a y to the 5th and a y cubed, so the most they have in common is a y cubed. So I'm going to pull that out. So again, I'm just dividing this by a 3y cubed, leaving me 1y squared minus 48 divided by 3 is 16. And I've taken out all the y's. So I'm at 3y cubed times y squared minus 16. Now, this guy is an unusual one. Okay, he's only 2 terms. And if you remember on our chart here, out. Okay, and the way you can work it out is you can say, okay, my c value, my constant, is still -16 here. And so -16, and I'm looking for an r and an s whose product is -16. So it could be a 1 times -16, -1 times +16, but their sums don't even come close to nothing because there is no b term. This is 0 b's or 0 x's in the middle. So we got to have them add up to nothing. And it turns out whenever your b term is 0, the way you want to go is you just want to square root that 16. 4 times 4 is 16. Now we want a negative, so one's got to be negative. But look what 4 and -4 add up to. They add up to 0. And that's why there is no b term in this problem. So it's just going to be 3y cubed. It will be a y. One will be a +4, and the other will be a -4. just like that. I'm going to show you the check right below this so you can see it works out, but this is our answer here. But I'm going to distribute, y squared minus 4y, and distribute, that's positive 4y, and negative 16. And now you can see what happened in the middle. The y terms canceled out. That's why it wasn't in the problem. Giving you y squared minus 16. We still have to multiply in that GCF to check it. That's 3y to the fifth. We add exponents, minus 48y cubed. 3y to the fifth minus 48y cubed. 3y to the fifth minus 48y cubed. We are guaranteed that this is our correct answer. 3y cubed times y plus 4, y minus 4. In our very last example, a little bit bigger problem. Let's look at our numbers first for a GCF. Everybody's divisible by 5, so let's pull him out. Myself more room than I've been doing. Let's look at our variables. Z to the fourth, z cubed, z squared. So they've got a z squared in common. So we'll pull him out. So when I divide this by 5z squared, 5 over 5 is 1, and I'm canceling out 2 of the z's, so it's just z squared. Divide this one by 5z squared, 30 divided by 5 is 6, and z cubed over z squared is just a single z, and divide by 5z squared, z squared over z squared is 1, and 45 divided by 5 is 9. So we're in pretty good shape. Now we just have to try and factor this trinomial. There's our 9, r and s. See, it could be 1 times 9. That adds up to 10. That's no good. Could be 3 times 3. That adds up to 6. That's a good sign. So let's go ahead and factor this. 5z squared must be a z plus 3 times a z plus 3. Okay, and I could go through and check this, but I guarantee this will work out. You will see this sometimes written as this answer, 5z squared times a z plus 3 quantity squared like that. Either one is perfectly fine with me, but just be aware they're the same. So if it's on a multiple choice test, sometimes the answer could be that, sometimes this. You just have to know those are identical answers. All right, that should take care of everything that you need to know to do today's assignment.